Hello everybody. Today we're gonna discuss about time dilation equation. So let's see where it came from. It came from the special theory of relativity, which was proposed by Einstein in 1905. It is also called the electrodynamics of moving bodies. So, what is special relativity? Special relativity is nothing but a consequence of the clashing of Maxwell's theory of light and the classical mechanics of Newton. So, according to Newton, space and time is absolute, and if we push an object any at at any inertia or any speed, then they would catch up any speed that we want. But according to Maxwell's theory, that is not possible. Nothing can go beyond the speed of light. So Einstein made a provided a peaceful solution to this argument by giving the world the special theory of relativity. It 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 tells us the importance of the speed of light, its constant nature, even in the daily life. So time dilation is one of the most important factor of special relativity, because it gives us the equation. It gives us a factor that we are going to encounter, which is a very essential in all the physics. And what is E square times S square? It was the aftermath of special theory of relativity. In June, I think, yes, in June or July 1905, Einstein published this theory of the paper of electrodynamics of moving body, and in November or September he published the mass energy relation, in which he gave E equals mc square. That's a story for another day, but today we're gonna discuss about time dilation. So it the special relativity contains more such absurd, some interesting things like relativistic velocity, like relativistic math, relativity of simultaneity, and Lorentz contraction or transformation, and so on. But time dilation is the most important because it drastically changed our insights about the nature of time. So here we have the great genius Albert Einstein, and let's see what we have. Let's see, we give a demonstration about demonstration. Before demonstration, I would like to give some insights, some points, some concepts that we require to have before we encounter this the concept of time dilation. That is the synchronization of clocks at which are at distance from one another. So if we take a clock on Earth and if we take a clock in space, so if the clock is stationary on Earth and in space it is in motion, then there is a certain time difference. So how do we synchronize the clocks at different spaces? Different spaces is given by this equation, this concept of time dilation. And the second is the constant nature of time. Constant nature of the speed of light. It's very interesting. The speed of light is unchanging. It's a constant number. It is fixed, eternal. No, it is like a boundary case. No material object can go beyond the speed of light. It is impossible. And why it is impossible, that we'll see in the further lectures. But for now, we focus on the weird nature of the speed of light. So what is speed? It is the how far you go divided by how long it takes you to get there. It means the distance by duration. it also means the distance means space covered, and the duration means time. So s equals d by t. Speed equals distance by time. So when you have a high speed, a weird speed, so it is obvious, it is natural, it is natural that the speed of the nature of the space and the time is also weird. The space and time itself acts weird. So one more one more concept of speed is the speed is relative, the speed is subtractive or additive, and and a body traveling in a constant speed in a constant direction can have whole right to claim to be at rest. So what does it mean? It means that if you are in a train, this is a very daily life example. If you are in a train, so that you are inside the train and the environment you see, the table, the person sitting in front of you or beside you, they are in rest. Why they are in rest? Because they are moving in the same speed as the train is moving. But when you see outside of the window, you see an amazing ambiguous thing, that the trees are at motion. Actually, if you see, the trees are at rest. But why are they in motion? It is because you are moving in a constant speed in a fixed direction, so you are at rest, and the trees which you encountered, which you are passing by, is in motion. It is a tree which are rushing by you, being you are at rest, and the trees are the stuff that is rushing by you, and it is the trees there which are in motion. And this both perspective is correct according to the frame of reference that we follow. So getting back into the lecture, I hope this concept of the constant nature of time is clear to you all. So when we see time dilation, we see the derivation. When we have derivation in non-trigonometric way, we'll focus on a device, a very nice device which was invented by Richard Feynman or Albert Einstein, I suppose, is a light clock. So let's see what is a clock. Clock is not a device for measuring time. There is no device in the universe which measures time. Clock is a device which measures how much time elapses in a particular interval, in a particular duration, how much time elapses. So a light clock is nothing. We can see in this diagram, this is 2 mirrors. These are 2 mirrors, and this red ball you see. This red ball you see over here is a light ball, and it just oscillates over and over and over and over between the 2 mirrors. So when it gets up, we say tick, and when it gets down, we say tock. You can see from here it is tick and tock. So one oscillation means tick tock. So there are 2 different concepts, there are 2 different phenomenons that we encounter when the light clock is at rest, and which is different from the light clock is in motion. So here is our genius Albert Einstein in a rocket, and let's apply some thrust to this rocket, and this is at motion. Here is a light clock, and this is at motion. So in rest, it is simple. In rest, the light ball has to just travel from up and down, up and down, up and down, and tick and tock, tick and tock. But this perspective changes in motion. The light, because this what do you call the light clock travels a distance inside the rocket, so the light ball has also to travel some more distance to the corresponding mirror and then have its nature of oscillation. So here is a light ball, so we see this is a light clock over here, but and this is the corresponding light clock. So this light ball has to travel from here to here because it is a distance, because the light clock is itself in motion inside the rocket, and then again from here to here. So this is one tick tick and this is one tock. So the main funda about here is the light clocks in motion. So yes, so these are the light clocks at different points in space at different time intervals. So this is a light clock, and this is the light clock after the second. And the light ball basically has to travel from here to here, and this diagonal part is more than this up and down because the distance is increasing. Okay, and let's say and later we will understand why it is L and L dash. This is for the sake of convenience, just nothing very complicated about it. The distance, the height between these two mirrors, the distance traveled by this light ball is L in here, and the distance traveled by the light ball in motion is L dash. So what is the ratio of the time elapsed? Means how much time elapses on the stationary clock as compared to the moving clock. So there is a time difference, so that is delta Ts. S is stationary clock, and the time in motion is delta Tm. So the ratio is L dash by L. So you may ask a question, and this is a very natural question: why is it that delta Ts is equal to L? Because the length is L, and in the case of delta Tm it is L dash. But why here the scenario has changed a little bit? It is because the more time will elapse on the stationary clock as compared to the moving clock. It means if you eat an apple on Earth and if you eat an apple in space, sitting in a rocket, luxurious rocket, so a person on Earth will feel like it has eaten that apple very fast as compared to the person eating the apple in space. So that is why it is delta Ts. Delta Ts by delta Tm is equal to L dash by L. So it's a diagonal trajectory. L dash is a diagonal trajectory, and L is the simple up and down, the perpendicular trajectory. And the moving clock slows as compared to the stationary one. Let's suppose by a factor of 3 means the stationary clock is slowing down by a factor of 3. It means the ratio is 3:1. It means that the ratio is 3:1 because the moving clock ticks slower as compared to the clock in motion. So it is equal to 3:1. And it means that, what it means, the clock in rest is elapsing more time than the clock in motion. Means if we multiply delta, the time duration of the clock in motion times 3 times, then we will get the time that is elapsed on the stationary clock. So this is one of the insights that we need to have here, why it is L dash by L. So I hope it is clear to you all. So next we're gonna focus, and let's for the sake of convenience, let's make this equation 1 over here. uh, Fantastic. Yeah. So we have, let me change the color. We have a beautiful yeah, right, that is a nice one. So the distance from, before we discussed over it, that we discussed that the distance is L, and it at rest in in the clock, in the clock in motion, let's suppose that it is moving, the clock is moving at velocity v, it is moving at velocity v. So we're gonna use the discrepancy of, we're gonna measure this discrepancy of, we will derive the equation by the famous, the first theorem of mathematics, the Pythagoras theorem. So this is a diagonal trajectory, and we already know that it is L dash, that the curved trajectory is L dash, and this perpendicular one is L. And what is the, if we take two light clock at different time, and so what is the distance covered by the light clock is given by the time duration times the velocity of the clock. So this is the v times delta tm is nothing but the distance covered by the light at particular, at the given time, that is delta tm. And one more interesting thing over here is the c is not v, because it is a speed of, because it is a light ball which is traveling from here to here. It is a light ball which is making a trajectory from here to here. So it is c times delta tm. So it is nothing but the distance covered by light times it is the measure of the distance which is given by the speed of light times how much time it takes to get there. That is c multiplied by delta tm. So we know from Pythagoras theorem, this is AB. Let me have over here, this is AB, and the hypotenuse, the square of the hypotenuse is given by the BC square plus AC square. So AB is L dash, so it is squared, and equals to AC is equals to V times delta Tm, it is squared, and it is and the BC is again L, so it is L square. So we will replace the value of L dash as C times delta Tm square, and if we have to do this, we get interesting results by doing this stuff. So there's nothing very critical mathematics, just simple arithmetic. So this I will take this v over here and take it this side. So I will get L square is equal to C square times delta Tm square minus V square times delta Tm square. So I can take this delta Tm square as common, so it is C square minus V square times delta Tm square. So again, so this L I can also write as the square root of C square minus V square times delta Tm. Okay, I have made a small mistake over here. This is not square, because it is a square root. Again, it is not the square. Sorry for the mistake, but there is no, I think, major influence about it. I think the concept is clear. So L from here, but from Pythagoras theorem, we derived as a square root of C square minus V square times delta Tm. So again, we will get back to our equation 1 from where we have started, and from here yeah, from here, from this equation 1, C delta Ts by delta Tm it is equation 1 is equal to L dash by L is equal to L dash by, we'll substitute the value of L which we got from here as delta Tm by V square minus delta Tm times the square root of V square minus C square. One more interesting, we'll apply little our brain, and we can also write this L dash as delta Tm times C from here. From here we can write as delta Tm times C. So what happened? This delta Tm and delta Tm down here will get cancelled, so we are left with C upon the square root of C square minus V square. And if we factorize it little more, we'll get, if we take C from here, then the C will again cut, and therefore we get our beloved equation that we were looking for, is 1 by the square root of 1 minus V square by C square. And this equation is very essential. This one is very essential. Why? It pops out in every places in the special theory of relativity. And one more thing that we need to focus upon is this 1 by the square root of 1 minus B square by C square is also called the gamma factor. So gamma factor helps us, makes our calculation little smaller, it makes it little easier, doesn't make us little more messier. So we got over here. So the ratio of the elapsed time on the stationary clock as compared to the moving clock is given by 1 by square root of 1 minus V square by C square. So again from we get to the equation 1 is delta Ts by delta Tm equals to 1 by square root of V square by C square. And we also know that this stuff over here is equal to the gamma factor. So it means that delta Ts by delta Tm is equal to gamma, which implies delta Ts equals to gamma times delta Tm. So see that, so here we get a mathematical derivation that the time elapsing on the stationary clock is more as compared to the time elapsing on the clock in motion. So if we have if we need to measure any discrepancy between the clocks, we can use this equation to measure it. And the gamma factor is always greater than 1. I hope you perform an example of your own to see it is greater than 1, because it is always be greater than 1. But if it is not greater than 1, then the delta Tm will be less than the delta Ts will be less than the delta Tm. Oops, I have made another mistake over here, because see, the speed of the light, is a funny mistake over here, funny thing. So because 0 is always greater than the velocity will be always greater than 0, and nothing, as we know, nothing can go beyond the speed of light, so speed of light will always be greater than v. So here we have the time dilation equation. Hope you understand that. But you still raise a question, why there is no time difference in daily life? Because the value of v is very low in daily life. So that is why the difference in time, the time discrepancy is very low. The time is independent of motion, only when v is less than light. If v is less than light, v is more than light, we will not experience any time. That is why light beams can travel large distance without without have any influencing about in its particles. See, the light are made of photons, and since they travel at such a weird speed, the time has itself no influence on them. That is why the speed of light is unchanging. That is why the speed of light is constant. But if we routinely travel at a world at velocity near the speed of light, we can have the sensation of time dilation, because the gamma factor gets bigger and bigger near the speed of light, and therefore the time dilation gets bigger and bigger. So hope this concept is clear to you all. That is why there is also a twin paradox. It was also solved by Albert Einstein. He imagined that there are two twins. His mother gave rise to two twins, and one twin stayed on Earth, and one other twin moved in traveled in a train a 1 year journey at the speed of light. The train motion was in speed of light. So when both when Einstein in train returned, then he was still young, but the Einstein on station was became an old man. So this is also the reason why the black holes elapses more time as compared to the time in space, because the time discrepancy is more and more. Time runs at a slow rate in case of a black hole. So that's all for today. Hope you understood this nice equation. Until then, take care.